will going to start deforming force in your physics unit 2. If any external force induced on a body and due to the application of force you can see the body is deformed. Initially the body was in this shape. After application of this force you can see body gets deformed. Okay. Then the force is known as a deforming force. What is restoring force? I will take an example and then I will explain. Suppose there is a spring you can see and there is a load. It is a load is hanging and P is a force by which we pull the spring, and by virtue of the property of material spring wants to maintain its shape in equilibrium. That means another force generated against this P which wants to retain its shape, that is known as restoring force. And here is the application of 5 forces which is very common and you need to know and make the conception very clear. One is the compressive force. If it is a body you can see this is a body, and if the arrows push together then it is known as compressive force. In this case if it is a body of any material and the arrows pull together it is known as tensile force. When the forces in applied in this direction as well as in this direction on a body it occurs shear force. In case of torsional force you can see there is a clockwise moment, it is a clockwise moment, and there is an anti-clockwise moment. In case of bending you can see there is a force which tends to bend a material, that is known as bending force. Okay, now we will going to explain what is the elastic body. If a force applied to a body and when the force is removed immediately the body gets back to its original shape, that is known as elastic body, and the property is known as elasticity. On the contrary, what is the plastic body? If you applied a force on a body and body gets deformed its shape, but immediately if you remove the force from the body cannot get to its original shape back. A constant deformation will be there, that is the plastic body. In case of very common question, in case of rubber or in case of steel, who is the most elastic? In very common sense we say that rubber is more elastic, but the actual concept is different, because if you want to make changes of the shape by putting tensile force as well as compressive force you can see you need to put more forces in case of steel to distort its shape. So in case of steel is more elastic compared to rubber. Okay, now we will explain stress. What is stress? Stress is explained as sigma. It's known as sigma. Okay, force by cross sectional area if it's a body, and P is a force applied. Okay, if it's a force and that is the cross sectional area, you can see force by cross sectional area is known as a stress, and the unit is Newton per meter square in SI units and dyne per centimeter square in CGS unit. Universal unit for stress Pascal. 1 Pascal equal to 1 Newton per meter square. Okay, in case of strain, change in length by original length, you can see it's a original bar. P is a force which is pull, that is you can see tensile force. So if you apply tensile force on a body it gets elongated, you can see the elongated shape here. Okay, so change in length, that means it was a greater length, L is greater than L0. So change in length L minus L0 divided by original length L0, that is the strain. But it is a unit less as because there is a unit, same unit, and unit upper and lower will be cut out. So it is a unit less, that is known as strain. Okay. So we have explained stress and strain. Now we know that Hooke's law. We will going to explain Hooke's law. Very important. Hooke's law. What is Hooke's law? Stress is proportional to strain within elastic limit. That is the Hooke's law. Stress and strain proportional to strain within elastic limit. As per the mathematical expression, if you want to know, sigma stress is proportional to strain. Okay. And if you want to remove the proportionate sign, you need to bring a constant, that is E. E is a known as a proportionality constant. Another name is modulus of elasticity or Young modulus. Okay, so this much for this class. Try to resolve the assignment, and if you have any problem so please feel free to communicate through the mail. Thank you very much.